All right, so you've built VPCs, you understand subnets, maybe you've even wrangled a transit gateway. But how do you make that leap from the basics to building a network that can truly power a global enterprise? In this explainer, we're going to break down the architectural patterns that separate day-to-day operations from enterprise-grade design.
So let's start with the big question, right? We all begin our journey by putting everything into a single VPC. It's simple, it works. But why do large organizations avoid that model like the plague? Well, the answer comes down to three things: scale, security, and a concept we're really going to focus on today, which is the blast radius.
We're going to move past the building blocks you already know, things like internet gateways and NAT gateways, and we're going to start talking about the principles that define a truly resilient system. We're talking about governance, failure domains, and operability. You see, these are the concepts that will fundamentally change how you approach network design.
To build like an enterprise, first, you have to think like one. And that all starts with one foundational, abstract concept that's going to guide all of our design decisions from here on out: the network domain.
So what exactly is a network domain? Now, this is the critical piece. It is not an AWS service. You can't click on it in the console. It's a design abstraction, a way of logically grouping network functions that all share the same trust boundary, handle similar kinds of traffic, and, crucially, would all be impacted together if something were to fail.
And this table here does a great job of clearing up a really common point of confusion. A VPC, well, that's a concrete AWS resource. It lives in a single account in a single region. A network domain, on the other hand, is a design concept. So a single domain, let's say your security inspection services, it might actually span multiple VPCs or even multiple AWS accounts to get its job done. Understanding this distinction is absolutely key.
Okay, so now that we've got that concept down, let's look at the blueprint. In the real world, this abstract idea of domains actually shows up as 5 distinct, very practical implementations. Let's walk through the 5 core enterprise domains right now.
First up is the Ingress Domain. This is the front door to your entire cloud environment. Its one and only purpose is to handle every single bit of traffic coming in from the public internet. Its responsibilities are crystal clear: filter and route that internet-facing traffic, and provide that first line of defense with services like AWS WAF for application attacks and Shield for DDoS protection. The components you see here, like CloudFront and application load balancers, they are designed to be highly available and stateless. That means they don't hold any long-term session information, which makes them incredibly resilient to failure. Let's move on to the next one, the inspection domain. I want you to think of this as your central security checkpoint for all traffic that's moving between the different parts of your network.
Its job is deep packet inspection. It's looking at traffic all the way from the network layer up to the application layer, using what we call next-generation firewalls to enforce security policy. Components like the gateway load balancer make it possible to just slide these firewalls transparently right into the traffic path. And here's the crucial point: the inspection domain never, and I mean ever, hosts business workloads. It exists purely for security.
All right, now we get to the heart of the architecture, the workload domain. This is where your actual business value lives. It's where your applications run.
So this domain, it's going to contain all of your application VPCs with services, like EKS, EC2, RDS. The single most important design principle here is that it passively receives traffic. It should have no public IPs, and it should never connect directly to the internet. It is protected by all the other domains, which dramatically limits the blast radius if something gets compromised.
But hang on, what happens when those applications need to talk out to the internet? For that, we have the Egress Domain. This is the single, controlled exit point for all of your outbound traffic.
So whether your application needs to call a third-party API or download a software update, all of that traffic gets funneled through the Egress domain. This gives you one single choke point to apply consistent security policies, logging, and filtering. Using components like NAT gateways and egress-specific firewalls, it's all about control.
And finally, we have the shared services domain. This is the central hub that provides all the common, essential services that the other domains rely on to function properly.
Think of services like your directory services for authentication, Route 53 resolvers for centralized DNS, and endpoints for your logging tools. Putting them all here prevents duplication and ensures you have consistent operational management across the board. And that is key to controlling the blast radius of just a simple operational mistake. So, we've laid out the 5 domains, but you might be asking, why go through all this trouble?
The answer is the single most important concept in building resilient architecture: controlling the blast radius.
This is the one question that every architect has to ask themselves constantly. It is not a matter of if a component will fail, but when. And when it does, how big is the explosion? Does it take out a single server, an entire application, a whole line of business, or does it take down your entire global network? The 5-domain model is designed specifically to contain these explosions.
Just look at this slide. It shows the hierarchy of failure perfectly. A subnet fails, that impacts an availability zone. A VPC fails, well, that might take down an entire application. But a misconfigured transit gateway? That can impact an entire region. Your design choices directly map to business risk.
And that leads us to this critical design lesson. A transit gateway is an incredibly powerful tool for connectivity. But if you just propagate all your routes everywhere automatically, it becomes an amplifier of failures, not an isolator. A single bad route can spread instantly across your network and cause a region-wide outage.
So, how do we put all this together? Let's quickly summarize the design habits and the patterns that mature organizations use to build these resilient, scalable, and secure networks on AWS.
So how do you build like an enterprise? First, use AWS accounts to create hard boundaries for your network domains. Second, treat every single TGW attachment as a security boundary, not just another connection. Third, you have to meticulously control trust with route tables and never, ever rely on automatic propagation. And finally, operate with a zero-trust mindset. Trust your logs, trust your metrics, not assumptions.
And that brings us to the final thought. It's pretty easy to build a network that just routes packets from point A to point B. The real challenge and the mark of a true enterprise architecture is building a network that is designed from the ground up to survive failure. Thanks for watching.